Okay, so we're just going to go over the warm-up really fast. So I am going to just rewrite out our rule again, just because I can, and some people need to see it. So remember, if I have log base b of x equals y, I can rewrite that as b to the y equals x, right? Oh, if and only if, sorry. And it can go backwards. So if I have an exponent, I can write it as a log using the same rule, just rearranging my variables. So that means the first one says rewrite as exponential form. That means I'm going to rewrite log base 5 of 125 equals 3 as 5 to the third power equals 125. And the second one would be 9 to the negative 2 power equals 1 over 361. Whew, which is not correct. I bet that's supposed to be log base 19, not 9. So 6 to the third power equals 216. That's got to be a typo. I bet that's 19. I'll have to fix that. Okay. And then D would be 1/9 squared equals 1 over 81. And then going backwards, writing from an exponent to a log, this would be log base 4 of 16 equals 2. And then log base x of y equals negative 4. And log base 12 of y equals x. And then log base a of b equals 3. Okay? Questions on any of those? For those of you who were not here yesterday, just go ahead and look at the video and the notes, okay? So we're going to go ahead and move on. I am so sorry. After I ate, there's something in my throat. So I'm going to just read this, I guess, and talk about it a little bit as we go through it. It says for any positive number other than 1, any positive number other than 1 can serve as the base of a logarithmic function. And why, why is that? And I just want to, I'm going to make this a little smaller so I can talk about that a little bit. So, because, guys, remember, if I had log base 1 of 3 equals whatever. Remember, I could say 1 to what power equals 3. That doesn't work, right? 1 to, there's 1 to no power equals 3. Because 1 to any power is always, what's the answer to that? 1 to any power, it doesn't matter what power it is, what's my answer always going to be? So what I'm asking is, what's 1 to the 6th? What's 1 to the 100th? What's 1 to the 50th? 53rd? What are all those? What is the answer for all of those? What's 1 to the 6th power equal? 1. 1 to the 100th equals 1. 1 to the 53rd equals 1. That's why it's any positive number other than 1. My base of a logarithm can't be 1 because the answer for every single logarithm could only be 1. For this one that I just made up off the top of my head, of course, it's NA. It doesn't work because there's no power to 1 that would equal 3. So this is why it can't be, it has to be something other than 1. It cannot be a base 1. Okay? So it says can serve as a base of a logarithmic function. However, there are logarithmic bases that fit into certain applications more naturally than others. Base 10 logarithms, called common logarithms, log base 10 of x, are useful because they have the same base as the decimal system we use every day. Note this logarithm expression appears not to have a base. The base is implied. So when you see, I wish my dogs would be quiet. When I see log base 10 of 100. When I see a log without a base, so basically when I see this log of 100, and you'll see it a lot. You'll see a log without a base. That means base 10. Just like an x without anything in front of it means 1x. If I see a log without a base, it's log base 10. Does that make sense? So instead of them writing log base 10 of 100, they're going to just write log of 100. And that means base 10. Okay? So if it has no base, it's base 10. So one of the important things we need to remember. And then the next one is going to be the logarithmic base most widely used today is an irrational number, e, named after the Swiss mathematician Leonhard Euler. E equals 2.718288284, continues on. It's a non-ending, non-repeating decimal. The logarithm, log base e of x, is called the natural logarithm. And it's, and this is what it looks like. Although I always think it should be backwards and say NL instead of LN. But that is not a 1. It's an LNX, natural log of x. And then most calculators evaluate both the common logarithm and the natural logarithm. To evaluate a logarithm with some other base, wow, I was spelling really good. Some other base, the following conversion formula may be used. So in your calculator, even in your phone, and I'm going to try and pop my phone up here and try and see if I can see it, if you guys can see it and I can see it. There is where's the natural log base? Okay, so right here next to the 4, this is an Apple phone, but right next to the 4, you can see log base 10 and the natural log. So they've got those in the Apple calculator. They've got them right there for you guys to use. There is no other base for the log on this one, but there's ways. If you have calculators that don't have the other bases, this is a way to figure out what it is. And that's why we're going to talk about it, because not all calculators have ways to do logs with bases other than 10. Okay, so what this says, I'm going to kind of blow it up a little bit. What this says is if I have something that says log base a of b, I can rewrite that as log base c of b over log base c of a. And this is really, this is the part that I'm really going to use. This one right here. So if I have log base a of b, I can rewrite that as log base 10 of b over log base 10 of a. So I can put it into my calculator. So as an example, like this first example, I can write this as log base, not log of 9 divided by log of 2. Okay? Is everyone with me okay so far? So the big one, the big number goes on top, the base goes on bottom. Just kind of how it is. You can kind of see it anyways. I mean, I kind of see it this way. Like the 9 is a big number and it's kind of over the base. So the 9 goes on top of the 2 and I put a log in front of it and it's log base 2. And then when you go to your calculator, when you're doing it in your phone calculator, if you're doing it in your phone calculator, I'm going to put parentheses, clear, around the, I think I have to put the 9 in first. Yeah, around the, so I'm going to do parenthesis 9 log base 10, because, you know, in the Apple calculator, you have to put everything, you have to put the numbers in first, which is kind of weird. And then divided by, again, another parenthesis, 2, and then the log base 10, and then equals, and it should be 3 point, we're going to go to 4 decimals, 3.1699. Okay, 3.1699. So that's how we do this. We're going to do a few of them, and I'll do a few of them with you, and then you'll do a few, and then we'll talk about them again in a second. So the second one would be log base 10 divided by log base 2. So I'm going to do the same thing again. Okay, questions so far? And sorry I don't have any of my other calculators here, but if you have the little TI-30, like just the little handheld calculators, they'll have a log and a natural log on there. It probably won't say log base 10, it'll just probably say log, L-O-G, and that means that it's base 10. Same with the TI-84s. If you have and we're going to talk about other calculators that actually do different bases in a minute, we want you to be able to do this change of base in case you don't have a calculator that does different bases. Does that make sense? And I'm going to show you a calculator in a minute that does do different bases that you have access to. Divided by, oh, I don't think that helped. Oh, of course it did. Divided by 2 log equals. And the second one should be 3.3219. And then we've got, let me give myself room to write over here. Sorry, log base, log of 12 divided by log of 2. So in my calculator again, 12 log divided by 2 log equals 5 point, oops. And obviously I can't read either, you guys. Let's try that again. 3.58 496. So that's going to change the 9 to a 0, a 10, and the 4 to a 5. So 3.585. Okay. So now I want you to go ahead and try through I. Okay. So go ahead and do through I. Okay. So I'm going to go ahead and write out both the fraction, I guess, that we're supposed to be, the change of base fraction and the answer. So I've got, let's see, so this would be, oh, okay. This should be log of 3 divided by log of 8, which is 0.5283. And most of you guys are right. Just, if you're not, just check and see what happened. I guess that would be the best thing to say. And then we have log of 9 divided by log of 5, which should be 1.3652. Great. And then we've got, let's see, log of 2 divided by log of 7 should be 0.3562. And then for G, we should have, let's see, log of 7 divided by log of 2 is 2.8074. Sorry, there should be a point there that you could actually see. And then this one will be log of 38 divided by log of 3, which is 3.3111. And then we've got log of 9 divided by log of 6, which is 1.2263. Okay, and I had you stop there because I kind of want to, and I know it's not going to be on the video because I'm sharing I'm recording on so sorry, on the iPad, but I do want to show you this calculator, and I know that you guys have all seen Desmos. okay? If you don't have it on your phone, you've at least seen it on the calculator, on the computer, and you all do have access to it on the calculator because it is free. It's free on the calculator, on the computer, and it is free on your computer if you choose to use it. And the nice thing is, again, is the interface is the same whether you're using the app or you're using the desktop version. So can you guys see? You should be able to see the Desmos, right? Can you guys all see Desmos? Someone tell me yes or no.
Yeah.
Okay, thank you. Okay. I just didn't see the little green screen around. I was like, oh no, am I not sharing it? So if I pull up the little keyboard over here, notice it doesn't have log on there, right? Not there. But if you go over to this function button and I go to miscellaneous, if you see log here, that's log base 10. But look right next to it, it says log base A. That means I can put in any base I want. So if I click that button, notice it has my little base. So if I put in the first problem that we did, which was log base 2 of 9, I can put my 2 in there, go up to my parenthesis, put 9 in there, and then I get the same answer that I got, 3.1699. Okay? So I can put any of my answers that I just got in there super easy by going to the function button and then that log base A button. And I don't have to do the change of base formula. The problem is not all calculators have a different base that you can use. So you have to know how to do the change of base formula. So especially since you guys are juniors and you're going to be doing the ACT pretty soon, not all the calculators you have will have a log with a base on there. So you need to know how to do the change of base formula if they happen to have a logarithmic problem on the test. So you need to know how to do this. This is a basic logarithmic problem. So this is a problem that could be on the ACT. So if I were to do J says log base 4 of 14. So I just put the 4 in here. And then you can arrow over if you want. I just find it's easier just to click over there and then go 14. And then we get our answer, which is 1.9037. 9037. So I'm going to stop sharing there and go back to here, 9037. So this is 1.9037. So now I want you to go ahead and find the rest of them. And you can use any method you want. You can go to Desmos if you want. You can continue doing the change of base formula, which is fine. A lot of you got it correct. So whichever way you feel more comfortable with, I don't care. Just go ahead and get your answer into the chat. You guys are doing, those of you who are answering so far are doing great. And if you have any questions, please make sure you ask. So I'll give you another couple minutes to go ahead and get the answer, okay? Thank you. So if you have a calculator and you're not sure if it does different bases of logs, the easiest way to find out is to actually Google it. So I do want to say that that is the easiest way to find out. Just Google your calculator number or name or whatever it is, and then just say, like if you have a TI Inspire, which TI Inspires, by the way, if you have a TI Inspire, it does do different bases of logarithms. So if you have an Inspire, it does. Just Google your Brown calculator and put different base logarithms in there, and it should be able to help you find that, okay? So I just wanted to kind of get that on there for you guys. So here we go. I might get a little bit of lag because I'm sharing two screen. I split screened it when I'm writing on the explain everything, but we're going to try this and see how it works. So if I'm trying to find log base 2 of 0.5, again, I go to my functions button And then it's under miscellaneous, or you can just look through all three of them until you find, or all four of them until you find the logs, and it's log base A. So I've got log base 2 of 0.5, and it is -1. Okay? And then again, I go my functions and log base A, and this next one is log base 7 of 12.49. So that's going to equal 1.297. I believe that's a 6. It rounds to a 6. Yep. Okay. And then the next one changes a little bit because it doesn't have a base. It does have a base. It has base 10. So if you forget and put in the one with the base, you can go directly to the parenthesis without putting in a base, or I can put in base 10. It's still going to work, 0.5, and I get that answer. And I'm going to leave it up here. Or you can go just to the log and put in 0.5, and I should get exactly the same answer. It doesn't matter how you put it in. I'm going to get the same answer, which happens to be -0.3010. Okay? And then the next one, again, functions, and it has no base, so I'm just going to do the log of 136, which is 2.1335. Okay? Questions so far? And then the last two, and then I'm going to talk about this a little bit. The last two say ln of 51. That's remember, ln is the natural log according to our paragraph up above. And if you look on the right above the logs on my calculator here, it says ln. So I'm going to push ln of 51, and I'm going to get 3.9318. Okay? And then the last one, again, is natural log of 136 this time. 136 is 4.9127. Okay. So I'm going to make this there we go. Bigger here. Okay, so I do want to talk about why this number. Let's just pick one of these, and let's pick this log base 10 of 136. Why is it 2.135? And I think I can get it approximately there for you, and why it's there, and maybe it'll help you understand the rest of them and why they're approximately where they're at. So remember, this says log base 10 of 136, right? And I can rewrite this as 10 to what power equals 136? Well, I know that 10 to the, I need it a little darker because I'm going to go on to the blue. 10 to the first power equals 10, and 10 to the second power equals 100. And 10 to the third power equals 1,000. Do you guys agree with that? Are you okay with that? That math? 10 times 10 is 100. 10 times 10 times 10 is 1,000. So I know that this answer right here, 10 to what power equals 136, has got to be between, 136 is between 136, that's what I want to write. 136 is between 100 and 1,000. So that means that my my exponent has to be between 2 and 3. And isn't that what I got? And it's going to be closer, because it's 136 is close to 100, means it's going to be closer to 2 than it is to 3. And I got 2.1335. Hope that kind of explains how this works a little bit better. And that's really what we're trying to find, is this exponent. And because it's not an exact factor of 10, it's going to be some decimal, and the calculators help find out what that decimal is, because it's a lot of work to do by hand, trust me. It's a lot of work to do by hand. So that's what we're trying to find is this exponent here that works. So I hope that helps a little bit. Okay. Next, we are actually going to go to start solving. So I'm going to need to use what we learned yesterday, right? Which says if I have log base b of x equals y, I can rewrite that to b to the y equals x, right? That's the inverse of it. So I can rewrite it. Those two equations are equivalent. I can rewrite those. So I can't solve for x. I don't know what my base is. I have no clue. I don't know what x is. And that's what they want me to find out on problem A. So I can't solve it as a log. I don't know. Guys, I think I missed a couple people who came in. I don't know how to find the answer as a logarithm because they didn't give me a base. I can't even use a calculator because they didn't give me the base. So I need to figure out a different way to find the answer. So if I can't solve it as a log, I'm just going to switch it to an exponent and see what it gives me there. So this gives me, if I switch it to an exponent, I get x squared equals 9. Right? Can I solve that? I need my chat box back. Oh, good. Oh, thanks, Emma. That's... I knew I needed to sign someone else back in. So glad you spoke up, Emma. Okay. So can I solve x squared equals 9? Do we know how to solve that one? Can I solve for x now? I'm going to wait till someone answers my question. Can I solve for x now? Yes, Paige, I can. I can square root both sides. How do I undo a square? Remember, how do I undo a square? I square root it. So if I square root one side, I have to square root the other side. So the square root of x squared is x, and the square root of 9 is
3.
Okay. Usually there's two answers to x squared, right? Positive 3 and negative 3. But logarithms, we can't use the negative side of it. So we're only going to say x equals 3. And there's my answer. Done, solved, finished. Okay. So now we're going to try the next one. We're going to do exactly the same thing. So I can't solve it as a log. Don't know what the answer is. So I'm going to rewrite it as an exponent. So this becomes x to the third power equals 125. Can I solve for x now? Yes, Marco, that is correct. Good job. So how do I get x? It's an x cubed. How does x cubed become x? What do I do to x cubed to get it to become x?
You cube it.
Cube root it?
Yeah, that thingy.
Yeah, cube root it. So if I cube root this side, I want to cube root, oh, I didn't leave myself enough room. I want to cube root that side. So the cubed root of x cubed is x. The question is, what's the cubed root of 125? So what that says, basically, is what number times itself 3 times equals 125? Yes, Jessica, good. And in the chat box, we have a couple people who have the right answer, which is 5. So 5 times 5 is 25, and 5 quarters is $1.25. So 5 times 5 times 5 is 125. Okay? So let's move to part C, and we're going to do exactly the same thing again. Okay? So this one says x to the 1/4 power equals 100. Oh, how am I gonna, oh my gosh, I can't even talk. How am I, there we go, how am I going to undo x to the 1/4? I want x to the 1/4 to become x, not x to the 1/4.
Do you multiply x by 1/4? Or do you divide it, I mean?
No.
And then, well, I don't know.
No, that's okay. That's okay. So, remember yesterday, Melanie, you weren't here, but remember, I'm going to come over here to the side a little bit. Let me come over to this side because there's more room when I have the notes done. Remember yesterday, what do I rewrite the square root of x as? How can I rewrite the square root of x as an exponent? Does anyone remember? That becomes x to the what power? So the rule says, there's a rule, and it says, how do I want to say it? If I have the nth root of a to the mth power, that becomes a to the m over n. Oh, that's good. So I have x to the first power, the square root of x to the first power. So that would become, this is x to the first power, right? And this should have a little 2 there. They don't have one because they assume we know that square root means 2. Just want to put that out there. So that means this becomes x to the 1/2. And if I have the cubed root of x, that would become x to the 1/3. And if I had the 5th root of x, that would become x to the 1/5. And if I had the 19th root of x, you know, I'm just pulling these numbers out of my head, right? That would equal x to the 1/19. So if I can go this way, can I also go this way? Can I go back the other way? So if I was given x to the, which is one I haven't used, 1/8, what would that become? That would become x to the, the 8th root of x, right? So let's look at this problem that we're working on here. And it says x to the 1/4. How could I rewrite x to the 1/4? Do you need to see what we just did? How can I rewrite rewrite x to the 1/4? How can I write it in another form? I'm going to do this problem 2 separate ways. So I can rewrite this in another form by saying, using this logic, which we just did here, I could say this is the 4th root of x equals 100. Now, how do I undo a 4th root? Well, how do I undo a 4th root is I take it to the 4th power. If I do it on one side, I have to do it on the other side. So that would be x equals, I don't know how many zeros that is. I do think I know how many zeros that is. I think it's 100, 100 to the 4th power. 8 zeros. 10 million. Okay, well, you can think of this as another way too. This says x to the 1/4. I want it to be x to the 1st power. So what would I multiply? I could take it to the 4th power both this way also, because 1/4 times 4 is 1. So that gives me x to the 10 million. So that's another way to think about it. Either way is right, whichever way is easier for you to understand. So you guys, I think we're just going to work through all these together, but please make sure that you're asking questions, okay? Please. So I've got, this one says x to the 3rd power equals 59 over 126. So I cube root it, and I cube root it, and x is going to be the cubed root of 59 over 126. It doesn't simplify other than that. It's an ugly problem, but that's what it is. So now we're getting a little simpler. Okay. So this next little set of, let's see, set of 5, 6. The next ones are all the same, and it becomes 2 to the 4th power equals x. So I don't even really have to figure out. I just have to do calculator work on here. I need to switch it, and then I need to find out what 2 to the 4th power is. Does anyone know what 2 to the 4th power is? Yes, Jessica, very good. Okay. And then the next one says, again, the same thing. We're still doing the same thing. I'm still rewriting it as an exponent. 3 to the 5th power equals x. So x is going to equal, anybody know what 3 to the 5th power is? I don't. Okay. You can put that in your calculator and say, what is 3 to the 5th power? Yes, Jessica. Nice. Oh, sorry. This one says, how much time? Oh yeah, we're running out of time. Okay, 2 to the 0th power equals x. And we talked about the 0th power yesterday. What does 2 to the 0th power equal? Yes. It's 1. Very good. Okay. And if you put that in your calculator, by the way, if you put anything to the 0th power, you're going to get 1. Okay? So here we get 3 to the negative 2nd power equals x. So x is going to be, remember we talked about yesterday, if I have a negative exponent, all of a sudden, and I have a whole number, it's going to become a fraction, right? So this becomes 1 over 3 squared, which is 1 over 9. We talked about that yesterday. And then we get 49 to the 1/2 equals x. And we just talked about this. If I get anything to the 1/2 power, how can I rewrite that, right? We got this right here. Anything to the 1/2 power can be rewritten as what? A square root. So let me move this back over here again. So I can rewrite this as x equals the square root of 49, which equals 7. And then the last one says, what does the last one say? 1/3 squared equals x. So x is going to equal, what's 1/3 squared? Anybody know?
1.
1/3 times 1/3 is 1. So that's 1/3 times 1/3. And what does that equal? I'll write it out so you can see. Oh, wow. I'll write it out so you can see it. 1/3 times 1/3 is, yes, Jessica, nice. How do I multiply fractions? Top times top and bottom times bottom. So that's 1/9. And that's my answer. Okay?